With this video, we're going to begin our study of kinematics, which is the study of motion without studying the causes of that motion, without studying forces and so on. Okay, so we're just going to look at position, velocity, acceleration, distance, displacement, speed, those sorts of things. All right, we'll start with some examples. So a particle starts from the origin and moves in a straight line, such that its distance from the origin at time t is given by x of t. X is a function of t, is t cubed minus 9t squared plus 24 times t, for t equal and greater than 0, and x is measured in meters. And we want to find the initial velocity, that's x dot, dot meaning the derivative with respect to time, and the acceleration being the double dot, or the derivative of the position with respect to time. Okay, we want to find these at t equals 0. So our initial velocity will be x dot, okay, which is dx dt. Okay, well dx dt will give us 3t squared minus 18t plus 24. And we evaluate that at t equals 0, gives us 24 meters per second positive. So 24 meters per second in the positive direction. Okay, and we can take that as being to the right. Okay, so we can have a line like this, and okay, and we can have an object moving this way. Okay, and take to the right as positive, to the left negative. Let's find the acceleration. So that's x double dot. That's the derivative of the velocity. So that's the derivative of this thing here. So derivative of 3t squared is 6t minus 18. Okay, at t equals 0, the acceleration is minus 18 meters per second, and for our coordinate system here, it's directed to the left because it's negative. Okay, next bit. When and where is the particle momentarily at rest? Okay, well, it's momentarily at rest when its velocity is 0. So we set the velocity equal to 0, which is x dot of t to 0, which was this quadratic, 3t squared minus 18t plus 24 is 0. If we divide through by 3, we'll have t squared minus 6t plus 8, something easier to factorise. Factorising that will give us factors of 8, 2 and 4, factors of t squared, t and t, and we can have t minus 2 times t minus 4 equal to 0. Using the null factor law, we end up with t equals 2 and t equals 4 seconds. Now at t equals 2, its position, x of 2, so we need to substitute that back into this one up here. Okay, substituting that in, 2 cubed minus 9 times 2 squared plus 24 times 2 will give us 20 meters to the right, so it's plus. At t equals 4, the distance from the origin at t equals 4 is 4 cubed minus 9 times 4 squared plus 24 times 4 is 16. So it's less. In that space of 2 seconds there, it has moved closer back towards the origin. And now it's only 16 meters from the origin. All right, next bit. When is the acceleration, x double dot of t is 0, and the velocity at this time? Well, the acceleration, x double dot of t set to 0, means we need to set this one here, 6t minus 18 to 0. Solving that, t minus 3 is 0, t equals 3. At t equals 3, its velocity, x dot of 3, we need to substitute that into here, into the quadratic. 3 times 3 squared minus 18 times 3 plus 24 is minus 3 meters per second. It's a negative quantity. It is moving at t equals 3 seconds. The particle is moving to the left on our coordinate system. Okay, that's in the direction towards the origin. Now, if we do sketches of these, if we take our velocity here and sketch that, we have at t equals 0, we have 24. And then its velocity decreases, it goes negative, so it's turned and is now moving the opposite direction, and then at t equals 4 it's now turned and moving in the positive direction. Positive v means moving to the right, negative v below the axis here means moving to the left. Our position function was that original cubic, which we had up here. If you remember this cubic here, t cubed minus 9t squared plus 24t, plotting that, we get this. It's not a plot, sketch, sorry, I should say, it's a sketching this. Okay, and the acceleration was 16t minus 18, so here we go, it's this straight line here, constant acceleration. Okay, and these are all sketched for between t is between 0 and 6. All right, now displacement and distance. Okay, I need to say something about displacement and distance here. We need to be very careful. Okay, if I walk in a circle, let's say I walk in a circle like this, and let's say the radius is just 2 meters. Okay, if I start here, this point here, and I walk around the circle, let's just say I go clockwise, doesn't matter what direction, I go clockwise, and I return to my starting point right here, then my displacement is 0. My net displacement is 0. But my distance traveled, okay, that distance will be equal to the circumference of the circle, and that'll be 2 pi times 2. So that'll be 4 pi units, okay, whatever units I'm measuring it in. So displacement is the net difference between my starting and final position, so it's final minus initial, and in this case walking the circle, my final and initial points are the same, and so my displacement is 0, even though I've walked a whole circle. My distance travelled is the actual distance around that circle, the actual circumference that I've travelled. They are two different quantities, so be careful with that. Okay, my displacement t equals 3, well that's just given by the original. X of 3 is 3 cubed minus 9 times 3 squared plus 24 times 3. That's 18 meters. So at t equals 3, I'm 18 meters from the origin. Okay, the distance though, this is where we have to integrate over the path that we've taken. Okay, so we need to, it's the distance covered is equal to the area under the velocity time graph. So if you look at this velocity time graph here, okay, we've got between, we want between t equals 3, so we want from 0 to 3, okay? So we want all of this. Now, the sign value of the integral for the area between 0 and 2 will be positive, no problems. But between 2 and 3, we're underneath the axis. Between t equals 2 and t equals 3, we're below the horizontal axis, and that integral will produce a negative value for that region. So we're going to need the absolute value signs here. So our distance will be, we need to split this down into two parts. The intercept occurs at t equals 2. So we need to integrate from 0 to 2, the velocity, 3t squared minus 18t plus 24 with respect to t. And then for the bit from 2 to 3, we need to take the absolute value of that integral. Otherwise, we'll have a negative result, which will subtract from this business here, which is not correct. Okay. Now, if I did subtract that business, that would actually give me the displacement, but I don't want that, okay? I want the distance traveled, so I want the total amount. So when I integrate all this, I haven't carried out the steps here, but the first integral produces 20. The second integral, I end up with the absolute value of negative 2. So altogether, that gives me 22 meters. The total distance covered is 22 meters, but my displacement is only 18 meters. Okay, so the distance is the area under the velocity time graph, where you take account of the negative parts by using the absolute modulus sign, absolute value sign, sorry. Okay, we could describe the motion over time, so we could draw a little timeline here along the axis. T equals 0, we start at the origin. At t equals 2, we're at 20 meters from the origin. Okay, but at t equals 4, we've moved back a bit, and we found that to be, what did we find that to be, 16 or something, was it? I think it was 16. Okay. Yeah, I think, yeah, t equals 4, we found that to be 16. Okay, and then at t equals 4, we turn around again, and we go off to the right in the positive direction, and thereafter our displacement increases. All right, that's it.